Gambler's fallacy is one of the biases of our automatic system from the duplex mind. Whereas this system is great at making fast decisions, it's horrible at making well-thought judgments, like quick probability calculations. It is therefore prone to errors and biases. Gambler's fallacy is the effect that occurs in gambling games with probabilities. When a certain outcome has appeared multiple times subsequently, people have two options: stick with the same option or choose something else. Some people stick with the same option because they think they are lucky and have a so-called hot hand. People following the gambler's fallacy would pick something else, or, when playing a game with only two outcomes, the opposite option. Gambler's fallacy occurs because even though the probability on a certain outcome doesn't change each trial, people still tend to make a choice that isn't based on probability theory. According to Tversky and Kahneman, 1971, this phenomenon is caused by belief in the law of small numbers. According to this law, people think that only a small amount of data is sufficient to derive a general conclusion. An example of this law can be found in getting grades back for an exam. When you and your 12 friends all have a 3, you are likely to think everyone has a 3. Gambler's fallacy is derived from the representativeness heuristic. This cognitive bias causes you to compare the chance of events happening to previous experience or what should be expected. For example, if you toss a coin and it shows heads 7 times in a row, you tend to choose tails as the next option. A sequence of 8 times heads doesn't match with what you think a random series looks like. People think this streak of heads is a small part of a bigger series of tosses, so they apply the law of small numbers here. This because in the long run, the amount of heads and tails is expected to be around the same. To see this effect in real life, we chose to play the first round of the drinking game Bussen with some people at the faculty drinks. We manipulated the first 3 cards of the game such that they would all be red. People suffering from gambler's fallacy should then say that the next card should be black, because there are already 3 red cards. Red.
Rood. Ik zeg zelf rood. Zwart. Zwart. Ze heet het rood. En dan gaan we nog een keer.
Rood. Zwart.
Oké, ho.
Zwart.
Zwart.
Ja, daar
6 keer fout. Je hebt best al zoveel rood, dus dan verwacht je dat eerder een zwart komt.
In this short video, we showed what gambler's fallacy is, why it occurs, and what it is derived from. To show this effect in real life, we chose to play the first round of the drinking game Bussen, because it was easy to manipulate. From our experiment, we can conclude that gambler's fallacy occurred about 50% of the time. The other 50% said to have used probability theory for choosing black. Those people have come to the conclusion that it could be better to choose black, because 3 red cards are already missing from the deck. The chance on a black card is then slightly higher. However, this statistic difference is small enough to be considered insignificant.